And finally, in our last video, we're going to look at the table below that relates the weight of a panda at different ages. And the ages are in months. Weights are in pounds. Now, once again, we're going to ask ourselves, what makes more sense? Does the age depend upon the weight of the panda? Or do you think the weight depends upon the age? And I would say the weight depends upon the age, which makes the weight the dependent variable, which would go in list 2. And the age would be then the independent variable, which goes into list 1. So, to our calculator we go. And once again, before we get started, let's hit the y equals button, and let's clear out those equations from the previous problem. And then we're ready to enter our data. So we're going to go to the list by hitting Stat and then Enter on Edit. And once again, clear the data. We're going to arrow up so that L2 is highlighted. And we're going to hit Clear, Enter. And we're going to left arrows and do the same thing with list 1. And then hit Clear and Enter. So we're going to enter the age and months in list 1. So we're going to enter 1, 2, 3, 4, 6, 8, 10, and 12. And then the weights in list 2, 2.5, 7.6, 12.5, 17.1, 24.3, 37.9, 49.2, and 54.9. Okay, so, and again, very important, make sure that list 1 and list 2 have the same number of entries in. And to take a look at this data, we're going to hit Zoom 9. And again, looks like the data fits pretty close to a line. So I would expect something in the area of 0.99 something for this one, just to make sure. So then we're going to run the linear regression. So the linear regression, we hit Stat, right arrow to calculate, and number 4, the linear regression. And we should have list 2 for our X list, or I'm sorry, list 1 for our X list, list 2 for our Y list, and again we want to store the equation in y sub 1, so we're going to hit vars, right arrow to y vars, enter on function, enter on y sub 1, and then we're ready to calculate it. So then we have the weight of the panda is equal to 4.92 times the number of months. So the weight is equal to 4.92 m. And what that slope means, what it represents, is that each month this panda would gain about 4.92 pounds each month, basically. And to go back to the calculator, the y-intercept is negative 2.55. So we're going to have minus 2.55. And the value of the correlation coefficient, we're going to go back to the calculator, is 0.997 if we round to the third decimal place. I hate it when I'm right, but I was right. So R is about 0.997, which tells us it's a pretty strong linear correlation. So then the next thing we're going to do is predict the weight of the panda that is 7 months old. So we're going to go back to our calculator, and if we go to the graph and do it graphically first, when we hit graph, now we have that line drawn down the middle of the data points, and this is where we do trace. And again, we want to be careful. We want to make sure it says y sub 1 up here, so we're going to down arrow till it says y sub 1, and there it is. And we're just going to hit 7. So you have a big X equals 7 there, and then we're going to hit enter. So the weight of a panda, 7 months old, is about 31.9 pounds. So we're going to go ahead and write this down. That's our answer for C, 31.9 pounds. Now, the second method you could use to find that is you could go to the home screen by hitting second, quit, and now calling back y sub 1 by going to vars, right arrow to y vars, enter on function, and enter on y sub 1, and then in parentheses we're going to put the number of months, which is 7. And then we're going to hit enter, and again we get 31.9 pounds. So get the same answer no matter which method you use. So follow your heart. Unless your heart tells you not to do it, then don't follow your heart. But whichever method you want to use, it's completely up to you. So in the next part of this, sorry about that, in the next part of that, in part D, we're going to predict the age of the panda that weighs 50 pounds. So we're going to go back to our calculator, and on the y equals screen we're going to put a second equation, and we want to know when the weight of the panda is going to be 50 pounds. So we're going to put 50 into y sub 2, and then we're going to hit graph again. And now we have a horizontal line that intersects that blue line. So we're going to calculate that intersection, which is choice 5. And then, is first curve something we want to find the intersection of? Yes. Second curve? Yes. So hit enter on that. And is that my guess? Yes. For some reason, I think they intersect there. And that doesn't matter because the calculator will automatically snap to the intersection. And a panda that is 50 pounds will be about 10.7 months old. So that is the age of the panda, about 10.7 months. And then for part E, it says explain why it does or does not make sense to predict the weight of a 10-year-old panda using this equation. And I'm just curious what you think about that. So I'm not going to talk about that at all. I want you to take a moment, write down why you think it would or would not make sense to use this equation to find the weight of a 10-year-old panda. And I'm just curious what you have to say, and I'm going to check that out on Monday and see what you have to say.